This is a recordings for section 5.3, the rational numbers. So this was important to review how to reduce fractions and things before we get into probability. Remember that rational numbers are numbers that can be written as fractions, right, in the form a over b. All right, you can use that slash, and it's probably better to use that vertical fraction bar. And of course, remember that the top is called the numerator and the bottom is called the denominator. Right? The following are examples of rational numbers: a quarter, negative 1/2, 3/4. 5 is also a rational number because it can be written as a fraction 5 over 1. And the same thing with 0. 0 can be written as 0 over any number. Right? So it is a rational number. When giving an answer in fractional form, the fraction must be reduced, i.e. there should be no common factor other than 1 between the numerator and denominator. We have several ways of reducing fractions. This is going to be really important because in probability, if you find the probability of an event and it ends up being 2/10, and you put 2/10 as the answer in MyLabs Plus, it's going to mark it wrong because you have to reduce it to 1/5. So make sure that all your fractions are reduced before you put your answers into MyLabs Plus. So we have two ways. The most common way is just to look for any common factor between the numerator and denominator and divide both top and bottom by the same thing, and keep doing this until you don't see a common factor anymore. You can also, for larger numbers, you could use a factor tree and to write the numerator and denominator as product of prime numbers and then cancel the common factors. So we'll show you both ways here just to remind you. Reduce 130 over 455 to lowest terms. First, divide by common factors. So we have 130 over 455, right? And you should easily see that both the top and the bottom are divisible by 5. So 130 divided by 5 will give you, we'll divide top and bottom by 5. 130 divided by 5 will give you 26. 455 divided by 5 should give you 91. And you will need to check whether or not this reduces any further. 26, you know 2 goes in because it's an even number, but that won't go into 91. And you think about 26, that's 2 and 13. That's the only factors of 26 are, other than 1 and 26, are 2 and 13. So you know 2 is not going to go into 26, so you can try to see if 13 goes into 91. And if you do that, 91 divided by 13, you'll actually get 7. So 13 does go into both of those. So this reduces 7, 26 divided by 13 is 2, and 91 divided by 13 is 7. So the answer is 2/7. So if you use factor trees, you take the factors of the numerator and denominator, or you think of a pair of factors that multiply together give you 130. You could do 10 and 13. It doesn't matter how you start. You can do 5 and 26, but 10 and 13 jumps out at me. Right, because it's just a 0 on the end. And then remember, when you get to where it's prime, it doesn't break down any further. You circle it, and 10 is 5 and times 2, and neither one of those break down any further. Right, and then you do the same thing with 455. Again, if you divide 455 by 5, you'll get 91, so it's 5 times 91. And you would have to check for factors of 91. You know, you could check if 2 goes in, 3 goes in. Once you get to 7, you'll see that 7 goes in 13 times. All right, so then you write the 130. Right, we're trying to reduce 130 over 455. So 130 is 5 times 2 times 13. You have to put time signs in there. multiplication signs, and 455 is 5 times 7 times 13. Again, in any order, it doesn't matter. And then remember that you can cancel any common factor, so you can cancel the 5s between the numerator and the denominator and the 13, so you get 2 7s. All right, if you didn't cancel everything, you would more than one thing, you would just multiply together what's left if there were 2 things left in the top, etc. So those are the 2 methods. 2 methods of many methods. Reduce to lowest terms, 2 and 6/8. You don't have to change that to an improper fraction. It's already mixed, so all you need to do is reduce the 6/8. And 6/8, of course, both have 2 as a factor, so that's 3/4. Whatever you do the numerator of a fraction, you have to do the denominator. And don't forget, if you have a bunch of zeros, you know, I prefer to use the vertical fraction bar. So if you have a bunch of zeros, remember you can divide by top and bottom by 10, which will cancel one set of zeros. If you divide top and bottom by another 10, it will cancel those. Another 10 will cancel those. So right now, just dividing, and that's dividing really top and bottom by 1,000 because you did 3 10s. That would be 14 over 210. And then you can see, I see that 7 goes into 21 and 7 goes into 14. So I can see that top and bottom are divisible by 7. Again, if you like the factor tree approach, you can take that approach as well. But 14 divided by 7 is 2, and 210 divided by 7, well, 7 times 3 is 21, so that should give you 30. But you're not quite done because they're both even. Whenever they're both even, you would divide top and bottom by 2. So the answer, the final reduced fraction, is 1/15. So you might want to pause this video and try the second one. Again, we will not be allowed to use graphing calculators or TI-83s that might already reduce fractions for you. You're going to have to actually do them by hand. 308 divided by 418. Again, you use what other method you want. If you want to use factor trees, or I can see that both of those are even. So I would start out by dividing both by 2, which gives you 154 and 209. And that may not look like it reduces any further. 2 is not going to go into 209, so you don't need to check that. 3, the divisibility rule for 3 is if you add, like if you want to know if 3 goes into 209, remember you add the 2 plus 0 plus 9, you add the digits and you get 11, and since 3 doesn't go into 11, 3 is not going to go into 209. I use that rule a lot. That rule only works for 3 and 9. So if you add up the digits, you can check if 3 goes in. If 3 goes into the sum, then 3 will go into 209. But 3 is not going to work, obviously, since 2 didn't go in. 4 is not going to go in. 5 is not going to go into both of them because they both don't end in 5 or 0. You don't have to check 6 since 2 doesn't go in. 6 isn't going to go in. But you could try 7. 154 divided by 7. That gives you 22. 209 divided by 7 is not a real number, so 7, or not a whole number, so 7 is not going to go into both of those. Don't need to check 8 since 2 didn't work. Don't need to check 9 since 3 didn't work. Don't need to check 10 since 2 didn't work, but you check 11. 154 divided by 11 is 14. 209 divided by 11 is 19. So this thing does actually reduce. So you would just have to keep checking if prime numbers go into it. 154 divided by 11 was 14, and 209 divided by 11 was 19. And then you can see you're done because 19 is a prime number. So that's as far as that can be reduced. So you are going to have to be very comfortable reducing fractions when we get to the probability section. The other thing in this section is converting between mixed and improper fractions. Remember, an improper fraction is a fraction in which the numerator is greater than the denominator, such as 15/4, right? And it's totally fine to leave your answer as an improper fraction as long as it's reduced. If you get an answer like 7/3, that's a perfectly fine answer. You really only need to change it to a mixed number. If you were talking about like cups of sugar, you wouldn't really say 7/3. You would say 2 2/3 cups of sugar. But as long as it's reduced, it doesn't matter about improper or mixed. Remember, to convert from mixed to improper, you multiply the whole number part by the denominator. So the whole number part, which is this, by the denominator, and add it to the numerator, and then place it over the original denominator. If you're changing 3 4/5 to fifths, you're going to stay fifths, right? So remember, you do 3 times 5 plus 4, so that's 15 plus 4, which is 19, and you keep your denominator of 5, of course, right? You wouldn't all of a sudden change to a different fraction piece. So 4 1/4, you do, if you write it like this, it seems better. 4 times 4 plus 1. So 4 times 4 is 16, plus 1 is 17, over the original denominator of 4. It should be 17/4. To convert from an improper to a mixed number, you divide the denominator into the numerator, record the quotient and the remainder, and write the mixed number answer using the following form. Quotient, which always means answer, right? The quotient and then the remainder over the original denominator. So 5 goes into 42. Well, 5 times 8 is 40, right? So this guy's your remainder. So your answer, it went in 8 times, right? Went in 8 times with 2 left over. And of course, the original denominator is fifths, so this has to stay fifth. And then, of course, you check it using the fact that 8 times 5 plus 2 gives you 42, right? 711 divided by 20. 20 into 711. So that's going to be 30 something. If you divide it in the calculator, 711 divided by 20, you'll get 35.55. So you know it goes in 35 times evenly, and 35 times 20 is 700, right? So what's left over is 11, right? That's your remainder. This is, of course, your quotient. So 20 went into 711 35 times with 11 left over, 11 over the original denominator. And then, of course, you check it by doing 35 times 20 plus 11 and make sure that you get 711 over 20. Remember that when you convert to decimals, all you do is divide the top by the bottom. Of course, 1/4 we know is 0.25, but in the calculator we of course hit 1 divided by 4. Do not use that little fraction bar on your calculator. You use the division key. 1 divided by 4 and you'll get 0.25. If you try 1 in that fraction bar, it's going to keep it as a fraction. You want it to change it to a decimal. For 4 5/6, you can go ahead and do the 4, which is the whole number part. Hit 5 divided by 6 in your calculator, and that will give you 0.8333 repeating. And so remember that we put, how we denote that is we put a line over the 3 to indicate it's going on forever. So if we want to express a fraction as a percent, we will just change it to a decimal and then multiply by 100, right? We did the decimal to percent conversions already. So if we wanted to do 5/8 as a percent, we hit 5 divided by 8, which will give you 0.625, multiply it by 100, which means move the decimal over 2 places to get 62.5 and add a percent sign. So express 1/8 as a percent down here. So again, we just hit 1 divided by 8, which will give you 0.125. And then you change it to a percent by multiplying by 100 or moving it over 2 places. So this should be 12.5%. And always remember, the whole number 1 represents 100%. So if you have 1/8, you know that it's way less than 50%, which would be 4/8. And the last thing is converting from decimals to fractions. Remember, from decimals to fractions, you just read the decimal and write the fraction. Remember, so you locate the last digit of the number, you locate the place value of that. So instead of calling this 0.1, I'm going to say 1/10 because the 1 is in the 10th place, and 1/10 is just written as 1/10, like that, and that's reduced. 0.45, the last digit is in the hundredths place. Remember, it goes tenths, hundredths. So this is read 45 hundredths, which you write as a fraction, 45 hundredths, and then you reduce it by dividing top and bottom by 5, and you'll get 9/20. So convert 1.053 to a fraction. So we have 1 is the whole number part, and then the 0.053, we locate the place value of the last digit. It's tenths, hundredths, thousandths. So this right here is 53 thousandths. And then you're done because 53 is a prime number. All right, will not have a common factor with 1,000, but you should always check if your fraction reduces. That is the end of section 5.3.